So hello everyone, uh, welcome to Mission with You YouTube channel. So in this video we are dealing with the model question paper 1 of the embedded system design for the 6th semester. So we are dealing with the first model. In question number 1a, the question is define embedded system and classify the embedded system based on the generation, complexity and triggering. So the answer is, the definition of the embedded system is, an embedded system is a combination of three types of components, mainly hardware, software and mechanical components, and it is supposed to do only one specific task. So there are four types of generations based on generation: first generation, second generation, third generation and the fourth generation. In first generation, these embedded systems are built around 8-bit microprocessors like 8085 and the 4-bit microcontroller, for example digital telephone keypads. In second generation, these embedded systems are built around 16-bit microprocessors and 8 or 16-bit microcontrollers, for example SCADA system. In third generation, these embedded systems are built around the 16 to 32-bit microprocessor or a microcontroller, for example robotics, media, etc. In fourth generation, these embedded systems built around system on chips, that is SoCs, and these are highly complex and very powerful. For example, smartphones. So next one is based on the complexity. In this, there are three types of complexities: small scale, medium scale, and the large scale. In small scale, it is simple in application needed. Performance is not time critical, and these are built around low performance and low cost 8 or a 16-bit microprocessor or a microcontroller, for example electronic toy. In medium scale, it is slightly complex in hardware and firmware requirements, and these are built around medium performance and low cost 16 or a 32-bit microcontroller or a microprocessor, for example industrial machines. In large scale, it is highly complex hardware and the firmware. It is built around 32 or a 64-bit RISC or a CISC microcontroller or a microprocessor, and these are responsive in time critical, for example mission critical applications. Next one is based on the triggering. In triggering, these embedded systems which are reactive in nature can be classified based on the triggering. Reactive system can be classified into two types: event triggering and the time triggering.
The next one is 1B. So here is the 1B question. Explain the following. First one is optocouplers, ZigBee, Wi-Fi, SPI bus and the USB. So in optocouplers, it is the solid state device to isolate two parts of the circuit. Optocouplers combines an LED, a phototransistor in a single housing or a package. These optocouplers is used for the suppressing interference in data communication, circuit isolation, high voltage suppression, simulation suppression, and the intensification signal. And this is the optocoupler circuit diagram, or we can say a block diagram. So you can refer this block diagram in the exam also. The ZigBee is targeted for the low power, low cost, low data rate and secure application for the wireless personal area network. The ZigBee specification supports a robust mesh network containing multiple nodes. So the ZigBee operates worldwide at the unlicensed bands of radio spectrum, mainly at 2400 to 2484 GHz. The ZigBee supports an operating distance of up to 100 meters and a data rate of 20 to 250 kbps. So ZigBee is primarily targeted application areas like home and industrial automations, energy system, home control, security, medical patients tracking, and logistic and the assistant tracking and sensor network and active RFID. So next the ZigBee terminology is ZigBee device falls under any one of the following ZigBee device category. That is, we can see here in the diagram, following ZigBee diagram. So here JC means ZigBee coordinator, JED means ZigBee and device,
And the next JR means ZigBee router. So in ZigBee coordinator the ZigBee coordinator acts as a root of the ZigBee network. The ZigBee is responsible for initiating the ZigBee network, and it has the capability to store information about the network. So you can refer this diagram and the following information for the ZigBee. The next one is the Wi-Fi. Wi-Fi, or the full form of Wi-Fi, is wireless fidelity. It is the popular wireless communication network for the network communication of the device. Wi-Fi follows mainly IEEE 802.11 standard. You can write this or the just skip in the exam. So this is the Wi-Fi diagram. You can refer this. Wi-Fi is intended for the network communication, and it supports intent protocol IP based on the communication. So in the IP based communication, each device is identified by an IP address which is unique to each device on the network. The Wi-Fi router is responsible for restricting the access to a network, assigning IP address to the device on the network. Routing data is packed to the intended device on the network. So the hardware part of it is known as the Wi-Fi radio. So Wi-Fi operates at the 2.4 GHz or a 5 GHz of radio spectrum, and they coexist with the other ISM band device like a Bluetooth. So you can refer this Wi-Fi router, Wi-Fi device 1, device 2, device 3. These all are connected to the Wi-Fi router. We can access the internet through the Wi-Fi router. So third one is the serial peripheral interface, that is SPI bus. The SPI peripheral interface bus is a synchronous bidirectional full duplex 4-wire serial interface bus. We can see here in the it is a full duplex 4-wire serial interface bus. The concept of SPI is introduced by the Motorola. SPI is a single master unit slave system. It is possible to have a system where more than one SPI device can be master, provided the condition only one master device is active at any given point of the time, and it should be satisfied. So master in slave out, that is MISO, signal line carrying the data from the slave to master device. It is also known as a slave output. You can see in the diagram. The same is given in the paragraph here. So you can refer this. And the next one is universal serial bus, USB. Universal serial bus, USB, is wired high speed serial bus for a data communication. The first version of the USB is USB 1.0, was released in 1995. USB communication system follows a star topology with a USB host at the center and one more USB peripheral devices. A USB host can support connections up to 127, including slave peripheral devices and the other USB hosts. The figure illustrates this is the figure and which illustrates about the USB connection and the USB host hub. And these are the devices that are connected to USB. This is you can refer these contents for the USB. So these are the answers for the 1A 1B question. In the next video we will see the answer for the 2A 2B question. If you like this video, please subscribe to our Mission with you YouTube channel, hit the like button and also share with your friends. Thanks for watching.